Alright, so in the last two videos, we talked about the smoothing methods, right? So we introduced two kinds of smoothing method, which is the simple moving average method and the exponential moving method, right? So both of these two methods belongs to smoothing method. So actually we just want to draw a smooth line so that the random fluctuation will not affect our prediction, right? So we use the estimated value to make the prediction for the next time point. So this is about the smoothing methods. And another class to model the time series, we call it is multiple regression based methods. Right, so for this part, for the regression part, I think you should be very familiar right now because it's just based on the chapter 16, 17, and 18, which is for exam 2 material. All right, so for the multiple regression based models, we say the good thing for this model is we can not just make the forecasting about the next time period. We can also make the forecasting about a kind of a little bit further future, right, based on the model. And also once we have the model, we have the coefficients, right? We can interpret the coefficients so that we understand the model much better, right? And another good thing is the model is more stable, right? So it will not be affected by the outlier a lot. So of course the outliers will always affect the model, but will not be as much as the smoothing method, right? And the disadvantage for this regression based models will be for model the time series, you need to at least have the trend component. Right, so you must have the trend component, and sometimes if you have the seasonal component, you can also model it together with the trend component. But first, you need to have the trend component. Right? If you don't have the trend component, you cannot use the multiple regression based models. What you need to do? You need to use the smoothing method. Alright, so suppose we have the trend component for our time series, right? Then how we can model the trend, right? So for example, use this example. This is the New York City water usage, right? So it is about the annual water use in the New York City, and from 1898 to 1968, right? So this is the data I want to analyze, right? And then with the when I plot the data, I have the year at the x-axis, I have the daily usage as the y-axis. So this is, you see, what is the overall trend? Overall trend is increasing, right? So for this case, we can just fit a simple linear regression, right? So the year will be what? Will be your explanatory variable. The daily usage will be the response variable y, right? So everything will be everything will be the same, right? So you just fit the linear regression based on the year and the response variable y, right? So you will have exactly the same output as what you learn in the simple linear regression, right? And then based on the parameter estimates, you can get the estimated sample equation, right? So here should be yt hat. Right, so let's talk about modeling the trend before this example, right? So actually, when a time series has a linear trend, for this case, this is a linear trend, right? So we can just model it with the linear regression of yt on time, right? So we just consider the time as the explanatory variable x, right? So here, this is the population model. So why I didn't write mu of y? Because it is very hard to type like this, mu of yt, right? Because time series will be, the response will based on the time, right? So it is hard to write like this. So most of the time when you type in that, we will just bold it, bold the y. That means will be the mu of y, and then with the underscore of t, right? So this is still the same thing with mu of yt. All right, so this is just the population model for the simple linear regression, right? So the time is our x, right? So the model will be just if we handwrite it, so it will be just a beta 0 plus beta 1 x, right? So feel familiar with it? Sure, right? We have already learned about that a lot, right? So based on these parameter estimates, we can get the sample equation, right? So this is your B0, this is your B1, right? So for this case, it is not possible the year equals to 0, right? So that means it is extrapolation, right? So we cannot we say the B0 doesn't have the practical meaning because year cannot be equals to 0, right? But how to interpret this B1? What does this B1 mean? B1 means when x increase by 1, y will increase by 2.36, right? So what does the year increase by 1? That means the water used in New York City has a yearly increase of 2.36 liters per capita per day. Right, so got the idea? That means every 1 year increased, the y will increase by 2.36, right? So this is the interpretation about B1. Right, so the idea would be the same. We just consider the year, consider the time as our explanatory variable x. All right, so it looks very easy to model the trend component. But what if we do not have the linear trend? For this case, it has the linear trend. It shows the straight line. Right? What if I don't have the linear trend? Instead, I have a curved trend. Then you need to be careful. You cannot just use linear trend to model this curved trend. Although it shows an increasing trend, but it is not linear trend. Then you cannot use simple linear regression to model this curved trend. Right, so what you need to do, we have already learned that, right? We need to do the transformation. The most popular one will be using the natural log transformation about the y. Right, so here we do not make the transformation, natural log transformation about the year or about the time. We need to make the natural log transformation for the y. All right, so what does that mean? So this is the simple linear regression. Just consider it is linear, and then we just use the year and the cells. So this is about the cells. All right, so this is the time. Right, so based on this, I just consider it is linear, and then I do a regression like this. All right, and then I want to improve this model, but actually in time series this is not allowed. We will talk about this later. Right, so we need to change this curved relationship to linear relationship by what? By doing the natural log transformation. So in our data set, you will have a column about the time, which is the year or the month or whatever. All right, and then you will have the y response variable. For this case will be the cell. All right, and then what you need to do, you need to create another column. This column is based on the cell. I do the transformation of the cell. I create the natural log of cell for another column, and then I ask a jump or software to make the linear regression based on the time and natural log cell, not this original y. Then you will see the linear relationship between the time and natural log of y. All right, so then you will have the model here. All right, so what's the difference between these two? Which one is better? We look at the adjusted R-square, right? Okay, so since both of these two are simple linear regression, so both of these two have just a one variable, so we can also use the R-square to compare it, but to be safe, we can use the adjusted R-square to compare these two models, right? So you can see that this model is much better than this model, right? So remember, in time series, you cannot use a linear regression to model a non-linear trend. Right, so this is very, very important. Right, so I will write here. Right, we say never use a linear regression to fit a non-linear trend. Right, always remember, if you have a curved trend, you need to make natural log transformation. All right, okay, so this is the first thing you need to get, or is the first thing you need to be careful, right, when you need to model the trend component. All right, so we're kind of done with the trend component, right? So nothing special. We just consider the time as the explanatory variable and then just fit the regression, linear regression, right? So if it is not linear, it is a curved relationship, then you need to make the transformation so that it follows a linear relationship so that you can model it with a linear regression. Okay. What about the next component, seasonal component? All right, so after we say if you want to model the time series, you need to have at least the trend component, right? So that means you need to first fit the trend component, and then after you fit in the trend component, you can add the seasonal component into your model. All right, so how you can add the seasonal component, because in the time series like this, right? So we see these points are not continuously recorded, right? So actually these points are for quarter 1, quarter 2, quarter 3, quarter 4, right? That's why we call it is seasonal component, right? So this pattern repeats every year, right? So if we want to just model this pattern, if we want to model this smaller pattern, how we can add this component into our model. We have 4 levels, right? Can this remind you something? We have a categorical variable now, right? So we have the 4 levels in this seasonal variable, right? So actually, if you want to model this seasonal component, you need to consider it is the categorical variable, and then you want to add this categorical variable into your regression by what? By setting dummy variables. Still remember that? Alright, so if you want to set the dummy variables, remember if you have 4 levels in this case, how many dummy variables you need? 3, right? We want the m-1 levels for the dummy variables. Alright, so you can randomly choose 1 out, and the other 3 will be the dummy variables. Alright, so here I just set number 4, the 4th quarter, as the standard, right? And then the other 3 will be the dummy variables. And then how you can set the dummy variables will be Q1. Actually, here for this part is hard to write in the words, right? So how you can set this dummy variable. If you want to set the dummy variable, this is your variable's name, right? So variable's name equals to 1 if it is in quarter 1, 0 otherwise, right? And then what about Q2? Q2 is still equals to 1 if this point is in quarter 2, 0 otherwise. And then Q3, the same thing, 1, 0 if it is in Q3, 0 otherwise. Right, so this is how you set the dummy variables. So it is exactly the same idea when we learn in the chapter 18 to 19, right? We talked about the dummy variables. All right, and then once you set the dummy variables, you can add these dummy variables into our regression, right? So remember, we first add the year as our x, right? And then now we want to add the seasonal component into our regression. So we need to add these 3 dummy variables into our regression, right? So first, what is the regression equation? When we talk about the equation, we look for the detailed number, detailed value for each coefficient, right? So we have yt hat equals to first b0, which is negative 147.8555, then plus 0.0752, which is about the year. We call it is x1, right? So we just label it, it is about the year, right? Next, plus 0.1567x2, which is about the quarter 1, and plus the next one, 0.0405x3, which is for Q2, and last one will be 0.0352x4, which is for Q3. Right, so this is the regression equation. All right, and then is the seasonal component significant? Seasonal component will be these 3, right? So is the seasonal component significant? Is the Q1 significant? Yes, right? Is Q2 significant? Yes. Is Q3 significant? Yes, right? So that means the seasonal component significant? Yes. All right, okay. So I will not state the reason here, but in your exam, of course, you need to state the reason. You cannot just give me a yes. All right, okay. So actually, when we add the dummy variables into the regression, after we model the trend component, we actually change from simple regression to multiple regression, right? So actually we consider this is x1, this is our x2, x3, x4, right? So this is our b0, b1, b2, b3, b4. So actually the interpretation will be exactly the same as what you learned in the multiple regression chapter. All right, okay, so I will not talk about the details for this part because it's just a repeated idea, right? So if you have any questions, just go back to the multiple regression chapter and watch the videos about the dummy variables, right? So I think there will not be any problem. Another thing I want to talk about is two concepts, right? The first concept is additive model, right? So what does that mean? We say this is our regression equation, right? So if you want to write the model, what will be the model? Will be mu of yt equals to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4, right? So this is for Q1, this is for Q2, this is for Q3, this is for the year, right? So actually the first two is about the trend, right? And the last three here will be about the seasonal component, right? So the relationship, when you model these two, actually you have plus, right? So for this kind of model, we call it is additive model. We are adding the trend component with the seasonal component. All right, so for this case, we call it is additive model. It's T plus S. All right, but what if we do the re-expressing about the y, response variable y? In our example, if you want to make the natural log transformation about y, then you will not have this additive relationship. Why? Because this, when you make the transformation, you are fitting these variables with natural log of yt, right? That means your regression model will be mu of yt, which is natural log of mu of yt will equals to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4, and x1 is about the year, and x2 is q1, and this is q2, this is q3, right? Because after the natural log transformation, we are making the regression based on the natural log of the y, right? But we want to know something about the y, right? So we can make the exponential to both sides, right? So you have the mu of yt will equals to e to the beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4, right? And then what is the relationship here? So beta 0 plus beta 1 x1 is about the trend, right? And then these three will be about the seasonal component. So actually it is exponential of t plus s, the trend plus seasonal component. So what is the relationship for these two then? It will equals to, by mass class, right? So it is e to the t times e to the s, right? So then this is about the trend component, this is about the seasonal component. But after the transformation, you will not have the additive model, you will have the next multiplicative model. Right, so now your y will equals to the trend component times the seasonal component. Right, so for this case, we call it as multiplicative model. Right, so these are the two concepts. If you didn't make the natural log transformation, you just have the additive model. But if you have the natural log transformation because it shows a curved trend, then you have a multiplicative model. So for this case, it doesn't matter at all. It just have two different names, right? Because after you make the transformation, the relationship between these two components will be multiplication, right? So it will not be additive. All right, so this is about the seasonal component. So first we need to model the trend component. And then if you see a seasonal component in the time series, you can add the seasonal component into the model of trend component by adding dummy variables. All right, okay, next we still have two components left, right? We still have the cyclical component and a regular component, right? Can we model these two? Actually, we cannot model these two, right? Because in the previous video, I have already talked about the cyclical component. The procedure of modeling the cyclical component is very complex, right? And also it is based on the understanding of the detailed data, right? So even though you know there is a period after model, the period is 5, but if you don't know how to interpret this 5, right, it doesn't mean anything, right? So at least for the cyclical component, you need to understand the detailed data, and then based on different data, you can make different interpretation, right? So here I will not talk about this component. I will not add this component into our regression because it will totally confuse you. All right, so but for the irregular component, you cannot model it, but you can check about it. Remember, irregular components is kind of the error, right? The random fluctuation, we call it as random error, right? So for random error, we have another name, which is the residual, right? So actually, we can still make the residual plot, but for this residual plot for the time series, remember the residual plot in the previous chapter for the regression. The residual plot is about the y versus the predict y with the x, right? Okay, so this is the residual plot you learned before, but for time series, the residual plot is the residuals versus the time. All right, okay, so there's nothing special. Once you have the model, you calculate the residual and then just plot the residual with the corresponding time, right? So there's nothing new, but the new thing is, for example, this plot, right? You will see some something not normal, right? It's not good, because for these two circles, for these two kind of outliers, right? So, but these two outliers shows a pattern, right? So what is the pattern? This point is the end of 2002. This pattern is end of 2008, right? So both of these two outliers is about the fourth quarter, right? So for this case, you can think about how you can improve your seasonal component, because it looks like your seasonal component is not very well, right? So from the residual plot, you can see the problems about your model, right? But again, you cannot model the irregular component. All right, so similarly, if you can model the cyclical component, you can we will have the additive model, right? If you make the transformation of the for the natural log transformation of y, you will have the multiplicative model, right? So here, this irregular component, it doesn't mean that you can model it. It's just the error term, right? So remember the error term in our previous regression chapter. So it is just the error term. It is not modeling about this component. All right, okay, so that's all I want to talk about the modeling methods. All right, so overall, there's nothing special, there's nothing new for modeling the time series. The only difference, it would be the only difference maybe just you consider the time as the x, and if you want to add the seasonal component into your regression, you consider it is the dummy variable, right? It is the categorical variable. You need to create m-1 dummy variables. All right, so next we want to talk about these, especially these two components, right? So we say the seasonal component is the most reliable part of the regression model, right? And the trend component is less reliable. Why is this? Right, so remember the trend component is what? The trend component is the overall trend, right? But overall trend, you cannot say it will 100% will keep this trend for the next moment. Maybe for the next moment it will be dropped, right, for this case. But for the seasonal component, since this pattern has been repeated for so many years, this pattern is very, very stable for each year. So that's why we say the seasonal component is the most reliable part of the regression model. All right, so we would expect, since it has been repeated for so many years, we will expect it to continue this pattern into the future. All right, but the trend component is less reliable, because the growth of the real world phenomenon cannot be maintained indefinitely. All right, okay, so this is the thing I want to talk about. And about the cyclical component, again, it must be based on one's understanding, right? So you need to understand the data first so that you can model it. Otherwise, you cannot model the cyclical component. You may learn it in the 400 level classes about the time series, right? But not in this class, right? Not in this course. Alright, so we are done with this chapter, and next 2 pages I just made a summary about this chapter, about these 2 methods, and also the general mistakes you may make in your research or the future work. All right, and you need to be very careful to not use the linear trend model to describe a nonlinear trend. We have already talked about that. You cannot use a trend model for short-term forecasting. So what does that mean? We say to model a time series, we have 2 ways, two classes, right? The first class is about the smoothing method. The second class is the using the regression method. Right, so if you want to make the short-term forecasting, we say smoothing method is better, right? If you use a trend model, you better use it for long-term forecasting because it will be more effective. Right, so again, the other way, you cannot use a moving average or exponential model for long-term forecasting because the smoothing methods can only forecast or make the prediction about the next time point. Right, okay, so this is the things you need to be careful. And this page is about what we learned in this chapter, so it's kind of a checklist, right? So be sure to check this, and you understand what's going on with this chapter. I think the most difficult part for this chapter will be the calculations about the smoothing methods, and other things is just about the understanding. Alright, okay, so just let me know if you have any questions. You can either email me or just schedule a hangout time, right? So we can meet together. Alright, okay, so just see you in the next chapter.